Hello, and welcome to this video on sugar concentrations and fermenting. Sugar is fundamental to fermentation and brewing. It is necessary to produce alcohol and carbonation. This would lead most people to think that more is better. But this is a case of too much of a good thing. This is seen in industrial high-gravity brewing. A batch made from a large amount of sugars and flavoring, which is then watered down at a later stage. This is a complex process, often subject to specific product lines. A point occurs at which the sugar concentration has an adverse effect on fermentation and yeast viability. This video explains where that point begins and why. Before getting into the details, some things need to be briefly explained. First is molarity, or in this case, osmolarity. How much sugar is there in a liter of water, or how many moles of sugar in a liter of water? This is often a weight to weight or weight in volume measure. Second is osmotic pressure. How much of the water inside or outside the cell exerts a pull on the cell's contents. This is relative to the amount of sugar inside or outside the cell, and the amount of water inside or outside of the cell. This either forces salts, ions, and other essentials into or out. This interferes with cell function if it does not kill the cell. Third, the yeast ethanol tolerance. The fourth and final are the cofactors, how much and how accessible they are. This is often a nitrogen yeast base, but that is not the only option. The effects of varying sugar concentrations can be demonstrated with 4 simple examples. A range of sugars will do different things to yeast. The first, and most likely scenario, occurs with low sugar concentrations. This could be wild yeast growing on grapes, or other low sugar content things that are on the surface, open and exposed to the environment. They contain a small amount of sugar. This will eventually lead to yeast cell growth. This is the usual pattern of lag, exponential growth, stagnation, and death. Nothing unusual. This is a short growth phase due to the limited quantity of sugar. The difference is the limited amount of sugar. It is less than the quantity in the cell. This gets absorbed into the cell over time and allows for metabolism without damaging the cell. Eventually it runs out. This stops fermentation and just about everything else. The limiting factor is sugar. The next level is one in which the cell has a sugar level, on par with that of surrounding environments. This is a richer media than in the first scenario. This includes examples such as ground flour. Much like the first scenario, it allows for the growth of the yeast population. The exponential phase is much longer, and this leads to a greater amount of conversion. Up to a point, this continues the trend from before. More sugar amounts to more growth and longer fermentation. It also carries a second practical limitation: the volume of cofactors. The most important for yeast cell growth being the nitrogen groups. This limits how much growth can occur, whereas lower concentrations are stopped before the nitrogen groups are used up. Despite that, the amount of sugar in this particular scenario is not used up by the time the nitrogen groups are used up. This leads to the next scenario, a high-gravity brew, something similar to ethanol or moonshine washes. This has a very large amount of sugar involved. It has a concentration of 0.4 kilograms a litre. For those used to the imperial measurement, that is roughly a pound in every quart. By comparison, a standard recipe for beer has 0.25 kilograms of sugar and malt per litre, which again is roughly half a pound per quart. This changes everything again. There is an excess of sugar. This leads to a population increase. As with others, this should increase until it runs out of sugar. It also uses all the available nitrogen groups. What is different is the osmotic pressure, the amount of sugar used in these washes. It is significantly more than that in average. This is 23.65 versus 15.13. It is well established that greater osmolarity leads to reduced viability. So, high-gravity beer and other brew washers use a variety of techniques to increase cell viability, fermentation productivity, and ultimately yield. This is largely a result of the osmotic pressure difference. It essentially floods the yeast cell's metabolic systems. This leads to a large amount of sugar entering the cell, or a large amount of the water which constitutes the cell leaving to reach an equilibrium with the environment. This reduces the lifespan of the cell. The final example here is one in which the sugar concentration is extreme, something beyond the range of any practical or realistic brewing wash, one that uses waste to prove a point. An example of 16 kilograms of sugar in 20-degree water leaves 66% dissolved, or 11 kilograms. In 20 liters, this is 0.55 kilograms a liter, nearly 50% more than a standard wash. This is limited by two factors. The first is volume and the second is solubility. Most sugars have a limited solubility based on the total volume and temperature. A smaller vessel has less capacity to absorb sugar. This is part of the reason industry can use high-gravity washers. They have very large volume facilities. It is also why yeast will suffer in this scenario. As is shown with wine studies, the greater the initial osmolarity, the greater the negative effect on yeast. The greater the sugar, the greater the lag phase, less cell viability, fewer cells, and lower ethanol tolerance. These are all undesirable. An extreme example like this would adversely affect yeast more than other examples would. This is exacerbated by the passive permeability of the yeast cell, a factor which responds in milliseconds. This leads to a degree of hyperosmotic distress. These are core to the cell death pathway. It is for these reasons that you begin to see a diminishing return on sugar as its concentration rises past a certain threshold. This will vary somewhat from species to species, but yeast overall has an approximate value of up to 0.4 of a kilogram in each liter of wash. Anything above this will lead to reduced returns on your investment and greater expense and time. Below this point, you will have increasing yields up to an equilibrium with the amount of sugar you have used. The yeast can only convert what sugar is in the wash. As a result, the 400 grams, or in this case 0.4 kilograms per liter, is the fulcrum of best value. Thank you for watching this video. Hopefully it has proven helpful and will save you money, time and effort in the future. Please post any comments, questions or suggestions you may have below.